Hey guys, welcome to my channel Sengupta's Creation. My name is Yona Sengupta. I am your tutor. Okay, so today we will start a new chapter, Combustion and Flame. The questions we will do first because the whole chapter I have done. I have made a video. After this class, I will just post it to my YouTube channel so you can just see. Okay, so shall we start? Let us start. Okay, let me share the screen for you all. Why is it not happening? Here it is. Okay, I hope you can see the screen. So today we will start with combustion and fuels. I think something is problem. So let us start. Okay, so the first question, I hope you can see here. I will just change the color here. I don't like this color. Let's keep this. Okay, so let us start. So, what are fuels? First, combustion and fuels. Now, some examples I would like to give you, which are the coal, wood, petrol, diesel, kerosene, natural gas, and LPG. These are some examples of substances which can be burned to give energy and are collectively known as uh, fuels. So we need to know that the what is the most common form of energy. Now the most common form of energy uh, is fuels. Fuels examples I just now told you, that coal, wood, petrol, diesel, natural gas, kerosene, LPG, and many more like this. Now, when we are talking about fuels, we are also talking about this topic. So, what is this combustion? Now, combustion is when a substance combines fast with oxygen, giving out heat and light. The phenomenon is known as combustion. Okay, so now we have learned about what are fuels and what are combustion. Is there any questions related to this? If you want, please tell me. Please tell me if you have any um, questions. Please subscribe my channel first of all. आप अगर सब्सक्राइब नहीं करोगे ना तो क्या होता है, मैं मेंटी नहीं करा सकती। इतने कम बच्चे अगर देखेंगे तो मैं मेंटी तो बिल्कुल नहीं करवा सकती ना। ओके, सो हम फिर टेक्स्ट में जाते हैं कि नेक्स्ट क्वेश्चन क्या है। द नेक्स्ट क्वेश्चन इज व्हाट इज कंबर्शन। After learning combustion, that a substance which combines fast with oxygen. So what is this combustible substance which comes from combustion? Now a substance under combustion is said to be combustible. For example, the examples of these are wood, coal, petrol, diesel, petroleum, gas. Now, these are the examples. You see, kerosene and LPG are not mentioned over here. Okay, because they are not combustible substances. Now, give two examples of carbon. Give two examples of carbon based fuel and one example to non-carbon based fuel. So the answer will be that coal and petrol are examples of carbon based fuels, and hydrogen is an example of non-carbon based fuel. Fuel contains, obviously contains carbon. So carbon based fuels, what are those? They are coal and petrol. Remember these. These examples are very important. Coal and petrol. And non-carbonic are, what are they? Are hydrogen. I hope you are understanding. Next is, what is a supporter of combustion? Supporter of combustion, example of supporter of combustion is oxygen. Why oxygen? Because a supporter of a combustion is a substance whose presence is essential for happening the combustion of another substance, like I just told you, which is oxygen. Now I will show you two. I will give you two activities in which you will see that oxygen is a supporter of combustion, and on other hand carbon is not a non-supporter of combustion. So this will help you to understand. You see these two examples. These two examples. So the first one says that show with a candle of an experiment. Show with a candle of experiment that carbon dioxide is a non-supporter of combustion. Okay, so this means that now what do we do in the experiment? We do that a candle is lighted and an inverted glass is uh, placed over it. Now, as soon as you put it, after some time, not immediately, after some time, what will happen is you will see that the candle is not glowing any more. The candle has stopped burning. Why? Because we know candle is burned as long as oxygen is present only. Now, when we put the inverted glass in the what do we say, the candle, what happens? It creates a shield. Some amount of air is inside the inverted glass, and some some amount of air is inside the inverted glass. So this inside the inverted glass, what happens is the candle uses this amount of whichever amount was kept in it will be uh, will help the candle to burn only when the oxygen is available in the present. Okay, so next is when all the oxygen of the air is used up, what will happen? It will gradually, the candle will go out. So here you see, here we have learned about the experiment that oxygen is a supporter of combustion. It is very simple. Now, next, let us learn about, okay. So, but next, let us learn about the carbon dioxide is a not supporter, not or non-supporter of combustion. Okay, we understood this? Okay, so let us show the experiment. What is the experiment? Experiment is that carbon dioxide is formed when washing soda or baking soda is treated with an acid. Okay, for example, we take vinegar. So now what we do in a container or in a bottle, we take some baking soda in it. Okay, after taking the baking soda, what we do is we all then some vinegar, we add some vinegar and some baking soda uh, mixed with the in the small bottle. Now what we do is we lit up a candle. After lighting up the candle, we fold a piece of paper with the lower end towards the flame. It will just slide a tilt a bit. You understand? Do you all understand? Okay. So after doing this, what will happen? The mouth of the bottle is placed near the mouth of the bottle. Remember the mouth, not the not beneath it. Okay, so the mouth of the bottle is placed near the upper end of the paper, and it is found that the candle stops burning. Why does this happen? Why does this experiment shows like this? It can also keep on burning, right? Why? Because since carbon dioxide is heavier than air, you see that why oxygen is why oxygen is a supporter of combustion. Why? Because it is not more heavier than the air. It is a little lighter. But in case of carbon dioxide is heavier than the air. So what happens? It travels down the folded paper and reaches the flame. What happens? As the gas does not support the combustion, the flame is extinguished. What happens? The flame of this thing, candle, is extinguished. Okay, so now let us move on to the next question, which is number 9. What is definition ignition define ignition temperature of a substance? This is easy. Okay, so what ignition temperature? Let me tell you. Now the lowest temperature at which substance catches air called its ignition temperature. So in other words, we can say that the temperature to which a substance must be heated before combustion takes place is known as its ignition temperature. Next one, Why does a paper cup containing water does not burn when placed over a flame? Why does this happen? Let us see now. Okay, so what happens? A fuel starts burning only when it is heated to its ignition temperature. What does it mean? A fuel will always start burning only when it is heated or is in the position of its lowest temperature, because you might remember this, that ignition means, what does ignition means? Lowest. I'm sorry, it's the lowest temperature. Okay, so what happens when a paper cup containing water is placed over a flame? The water becomes hot, but the cup does not burn. Why? Because the water takes away the heat from the cup and does not allow it to reach its lowest temperature point, at which the substance or the water can, or sorry, or the cup can catch fire or its ignition temperature. Now let us move on to the next question, which is, explain why a fire is extinguished by water. This is important. When, I hope you can see the full screen here. So when water is poured on burning substance, any burning substance, what happens is, it it absorbs the heat from the substance, and as a result the temperature of the substance falls down the ignition temperature and it stops burning gradually. So this is how water can extinguish or stop burning. You see, when we were kids, you must remember, we always have known that when we were kids, there is fire, we just pour some water and it will extinguish. But between this pouring water and into to extinguish the fire or the burning, there is a lot gap, there's much gap, where there is this information that when it is poured, what happens, it absorbs the heat, the water, yes, the it absorbs the heat from the substance. So when burning is always heating, right? So the temperature of the substance falls below the ignition or temperature, or the lowest temperature at which substances can catch fire, and it will gradually stop burning. Okay, so the next one is, a log of wood takes a longer time to start burning than wood shaving when heated in a flame. Now explain why this happens. Okay, a log of wood has a huge mass. Okay, but if you see, um, just a second. If you see, a log of wood has a huge mass, but in place of a wood shaving, on the other hand, has a very, much smaller mass to attain the ignition temperature more readily. It will more readily go to the lowest temperature. So a log or a large piece of wood takes a longer time than wood shavings to start burning. This is a very important thing, and the log takes a long time to attain the lowest temperature or the ignition temperature. On the other hand, that small wood shavings is generally much smaller in mass, and also is more readily going to the ignition temperature or the lowest temperature, which is all which so this is the explanation why that a log would take a longer time to start burning than wood shaving when heated in a flame. Okay, so now let us move on to the next question, which is define calorific value of fuel. Now, the amount of heat given by a unit mass of a fuel on complete combustion in air or oxygen is known as the calorific value of the fuel. For example, the calorific fuel if wood is 17 kJ per gram. Okay, so if we want to know that what is the unit of heat in this SI unit, international system of units, the answer will be in the SI system, the calorific value of a fuel is expressed in kJ per gram. So I hope you have understood what does it mean. Yes, Ritisha, LPG's full form is liquid petroleum gas, and CNG, the full form of CNG is compressed natural gas. Okay, understood? Now, if you have any questions, please tell me right now. I will just clarify it. I will give you 10 seconds. Please, 10 seconds. In this 10 seconds, please subscribe my channel and like the video. Hit the bell icon for receiving notifications of me coming online. Yes, I was planning to do the mentee, but many people are not here, so I will. And I have also fixed two mentees, actually one of 50, 50 questions and one of 100 questions. Can you believe it? It will be a great fun. For that, I need at least 1,000 likes. Please do like my video and subscribe my channel, please. And now, if you have some questions, please tell me, I will solve it for you. Hmm. Okay. Okay. So I will move on to the next question if you don't have. Okay. Don't worry. If you even don't have now questions, you will have when you are reviewing the questions I gave you. Anything, you will have questions, right? Just what you do is in the comment section or the in the description box I will give my number, so you can tell there if you have any questions. No, that is not my personal number. That is a number for my YouTube channel, because I know you all need teaching extra care, right? So that is why. So now let us move on. Okay. So the next question is, why should the ignition temperature of fuel not be below the room temperature? This is important. You must listen to it very carefully. Okay, so a fuel starts burning only when it is heated to a temperature called its ignition temperature, or in simple words, its lowest temperature. So this lowest temperature, or the ignition temperature of a fuel, is below room temperature. So then it will, what happen will be, it will start burning spontaneously, or even exploit. It can even exploit. Can you believe it? Yeah, it can even exploit. This is dangerous. That means, fuel is very dangerous and also important in our daily life, but very much dangerous than more than importance. Next is, which fuel has the highest calorific value? Okay, so you will see hydrogen has the highest, highest calorific value of the fuels. And the, what is the calorific value of hydrogen? It is 50, sorry, 150. I'm sorry, I was wrong. 150 uh, kg kj per gram. Okay, so next one, what is the next question is, why is hydrogen difficult to handle in the in gaseous state? Okay, so hydrogen has the highest calorific value of all fuels, which is 150 kg per gram, and it is very difficult to handle in the gaseous state, as it forms an explosive mixture with air. If it is in the below the lowest temperature, or the ignition temperature. Now, how is it used? How is this fuel used? Let me tell you. Now, this fuel is used in the liquid state. It is used as a fuel in spacecraft. Remember, in spacecraft. What is spacecraft? I will do one. I was thinking about doing an class about what is this spacecraft. I was also thinking about doing alien at 51 area, um, about aliens and more mysterious things. I know you also want to learn these. So I will very quickly, I will do those very fast. I will do those. If you can give me just 1000 likes, I just want 1000 likes. Okay. So let us move on to the next question, which is, what are fossil fuels and why are we looking for alternative sources of energy? So, what are fossil fuels? Now, fossil fuels are, the main fossil fuels are coal, petroleum, and natural gas. Now, you see, we are finding an alternative because these are natural, right? Coal is natural, coal comes from underground. Petroleum is also natural, and natural gas is always natural. Okay, so these all are natural, and natural resources we need to help them to save, right? So now the second question is, so this is why, however, their stocks are limited and they are looking for alternative sources of energy. Biogas is one such source. Example, this is an example of it. Next, let us move on, which is, what is anaerobic fermentation? We know what is anaerobic fermentation. We have learned in class 6, 7, and many other classes. Now, anaerobic fermentation is a fermentation in the absence of air. Okay, so the next question, what is biogas and how does it Does it burn? How does this biogas help us? Now, biogas is an alternative resources we have learned here in this part. You see in this part that fossil fuels thing. Yes, therefore we are looking this coal, petroleum, natural gas, and these all are natural resources. And for this, we are looking for an alternative, which is right now, which is biogas. This is one such source. Okay, so you see, methane, the main constitution of biogas, turns to be so I will tell you what does this biogas, just a second, what does biogas contain. So from here we understand that biogas contains mainly of methane and carbon dioxide, but methane has a large amount of, I hope you can see my screen. Yes, large amount of methane than carbon dioxide, but these two are the main. And it can also include very, very small amounts of hydrogen sulfide, uh, siloxanes, and some moisture in the air. So this is what we called as biogas. Now, we know that methane is the main constituent of biogas. So burns to give carbon dioxide and water vapor, and it burns completely, no soot. Now, what are these soot? Now, soot is unburned carbon particles, the carbon particles which are not burned, and carbon monoxide is formed from this soot. So when it burns completely, what happens? No soot is formed, and carbon monoxide is formed. So do we understand what does it mean? Okay. So now let us move on, which is, what is this happening? Yes. So there is a simple, I have told you a chemical equation. Okay, so what is this equation? Let us think about it. Now this equation is Hc4. What is this? Hc4 plus 2O square equals to CO2 plus 2H2O plus heat. So you see, I will just give this. It burns, so the heat is transformed, and then what happens? Oxygen is also present here. Then carbon dioxide, and it forms carbon monoxide. So this CH4 is the methane. 2H2O is the water. Just a second. This is a little bit problematic. I will draw it for you. CH is the methane. This this H2O is the water vapor. Next, this heat is the burns or the burning. Okay, and this carbon dioxide or the carbon monoxide, and obviously oxygen is present. Okay, so these are the This is the chemical equation. Next is with the help of a diagram explain how biogas is obtained. Now draw diagram and label. I have already drawn a diagram here. Let me just put it a little bigger. I hope you can see this one. So biogas is obtained by the anaerobic fermentation of cattle dung and domestic sewage. So anaerobic fermentation is the fermentation in the absence of air, we have learned already, and a mixture of methane, carbon dioxide, hydrogen sulfide is thus obtained when methane is being the main constituent. So we know that methane is the main constituent here. So methane is the main constituent here. So I hope you can understand what I am trying to say. Okay, now you see that the fermentation takes place in an underground tank, and that underground tank is this tank. You see this red mark, this tank. I'm not drawing it much. Okay, so the fermentation takes place in uh, the tank is made up of bricks, which can be called as the digester, which is this thing. This is the digester, right? So slurry of cattle dung and water is fed into the tank. On the fermentation of the dung, biogas is evolved and collected in the gas holder. So the gas holder made of steel floats over the slurry. The what is the slurry? This part. mm, so you see this part is the slurry. Okay, and it floats upwards, and the holder moves up when gas collects in it and moves down when the gas is drawn out. So this is what we call, this is the how biogas is obtained. Now might have already seen, you might have already seen that there is an outline pipe for a gas on the top. Now, tell us what is it about? It is on the top of the gas holder. This is the outlet. Can you see this? This is the outlet. Please follow the diagram here. This is very important. This is the outlet which is on the top of the gas holder. So this is the end. Next question is what are the disadvantages of coal? Okay, so this is important that a coal has the following disadvantages of fuel. Now, it contains compounds of nitrogen and sulfur as impurities, which also burn the form and the oxides of these elements. This is a great disadvantage, children. So these oxides are poisonous and pollute the atmosphere. So in an insufficient supply of, the second one is insufficient supply of air, and the coal burns to form carbon monoxide, which is also very poisonous in and pollutes the air, which is very bad. Next, I have prepared chemical formula or chemical equation for number 2, which tells us that C2C is This is, I think, carbon, and this is oxygen. Oxygen. And this is the main thing. This is oxygen, I told you. And when these two together burns, what happens? It forms a very simple substance which is known as carbon monoxide. Okay, so this is how it works. Next point, the disadvantages of coal is a lot of soot is formed when the coal is burned. Now, what is the soot? We have learned that the soot is the unburned carbon particles. Obviously, all the coals cannot be burned, right? So, then this soot is formed, and all that now number 4 is all that exists in coal is not combustible. So it is not a support for combustion. So there is a fair amount of waste which also hurts or pollutes our air, our surroundings, the environment, and coal dust causes health problems for miners. This is another thing. Yes, this is a very, very disadvantage, very bad disadvantage. Okay. Next, what we learned is about petroleum. Now we learned about, previously we learned about coal. Now we will learn about petroleum. Now, what is this petroleum? Petroleum is a thick, dark, strong, smelling liquid generally found deep under the earth, and it yields many fuels. Now, what is crude oil? Since we are talking about fuels, we are talking about petroleum. What are crude oil? So the unrefined petroleum is called crude oil. So we understand what are these. So now I will give you a fair chance. Now you can comment below that if anything is wrong, if you want anything. Yes, Kona. This is the examples. I've told you many examples. Yes. Okay, now YouTubers, I know you are thinking that whom I am talking with. Yes, I am talking with other people whom I am taking class with too. They are not watching in the YouTube right now, the live one. They are watching in another place. I will surely tell you that what is the place. But first of all, I at least want 1000 likes and at least 1000 subscribers at least. Okay, so I will surely tell you, and there you can join. And when you join there, what will happen is there you will not have to study. Actually, you will actually have fun. Okay, and there will be many teachers whom you single can interact. Many teachers with me, we can meet also. Okay, so now I will move on. Uh, Next one is, where is natural gas found and how is it used? Now, natural gas collects over petroleum inside the earth, and wells are sunk to extract them. Now, natural gas is directly transported through the pipes and are used. Now, next one is, why is methane considered a very clean fuel? Let us learn that methane, I'm sorry, I pronounced it wrong. Methane burns to give carbon dioxide and water vapor when it's completely burned. And as no shoot is formed, or unburned particles are not formed, methane is considered a very clean shoot. Now, there is a chemical equation I have written here, which is, the first one is the methyl, the second one is, this is oxygen, I'm sorry, this is, I think, water vapor. Okay, this is carbon dioxide, this is water vapor, and obviously heat is present when it burns. So this is what we know. Okay, so let us move on to the next question, which is, why is CNG preferred to diesel and petrol? Now, first of all, CNG's full form is compressed natural gas. Now, this natural gas is mostly methyl burn, which burns to give carbon dioxide, water vapor, and it burns completely, as also no shoot in this, also no shoot is formed, and methane is considered a very clean fuel. Now, methyl plus oxygen plus carbon dioxide plus water vapor plus heat, this is the chemical equation. Like methyl plus the natural gas or the air together makes carbon dioxide, water vapor plus also heat. Okay, next is that CNG is therefore preferred to diesel or petrol for use in public transport in some cities. Okay, so this is why CNG is preferred to diesel or petrol. Now, what are the characteristics of a good fuel, or mention the factors which should be considered while choosing a fuel? Now, good fuel should follow some characteristics which today we will learn, which are, it should be easily available, which is very important. The second one is, it should be very cheap, and the third one is, it should have a very high calorific value. Okay, now the fourth one is, it should have a low ignition point, or the from low to lowest ignition point, which is not lower, but which is not lower than the room temperature. Okay, why not below the room temperature? Or it can burn anything, start burning, or it can even explode. Okay, it can, it does not catch fire at the room temperature. This is what I mean. Next is, it should not burn too fastly or too slowly. Okay, it should be in a medium speed. So the next one is, the combustion of the substance should not produce harmful substances like soot and poisonous gas. Next one is, because they a good characteristics of good fuel, because they should not hurt the surroundings of us or the environment. Okay, so no residues should be left on combustion. So we understand here. Next, it should be safe to store, handle, and transport. Okay, next, what we will do is, the next question is, why are gaseous fuel better than solid and liquid fuel? Now, solid fuels like wood and coal are not good. Wood and coal are not very much, good. Why? Because of these following reasons. Let us learn about it. Okay, so the first one is on burning. They produce some very harmful gases. They leave solid residues. Okay, and felling of tree for wood is not advisable, because we don't want trees to go away. One day the trees will go away gradually, but we need to save it for sustainable resource, right? We have learned in geography, you should remember, sustainable development. We need to do that for wood. Now the stock of coal is also limited, so this is also a reason. The coal dust causes health problems. Many health problems can be caused from this. Next is that, okay, you all are asking my names. Let me tell you my name again. My name is Yona Sengupta. My name is Yona Sengupta. This is the spelling of my name, Yona Sengupta. Okay, I will just rub it. Okay, now liquid fuels like petrol, kerosene, and diesel burn more smoothly than the solid ones. However, what happens? They too do not ordinarily burn completely and produce poisonous gas or shoot on burning, or unburned carbon pieces on burning. So, gaseous fuels like natural gas and NCG, NCG is compressed natural gas, or LPG, or LPG and biogas. The full form of LPG is liquefied petroleum gas. Okay, these are better than any of the liquids or solid fuels which we just learned, or the which they are mentioned above. So these fuels can be burnt completely and do not leave any residues of truth. Now they have a high calorific value and lowest ignition point, lowest temperature, and moderate rate of burning, and are safe to handle. So this is why gaseous fuels are far way better than solid and liquid fuels. Okay, so now next question, which is, what happens when a candle burns? This is also important, that the wax of the candle is a solid fuel, right? So the wax of a candle is a solid fuel, and when we light a candle, the wax first melts and then gets partly vaporized. So the vapors pump to give heat and light. So carbon dioxide shoot and water vapor X is also produced. So this is what happens when a candle is burned. Next, is what are the different regions of a candle flame. Now, candle flame consists of following four regions, um, which is a bright blue region near the wick, where the this is the main four regions, but there are many more also. Different zones of candle. Just let me search the different zones of candle flame. Just a second, give me a second. Different zone of candle flame. I will like to show you here. Where did I? Yes, here is the part or the regions of this. Okay, so the first part is a bright blue region. So you see that this is the hottest part, this is the outer zone, this is the complete combustion of it. Now next is come the moderately hot. First the hottest part or the outer zone of the complete combustion, which is the blue part. Here it is written a bright blue region. The when we draw, you must remember, when we draw a picture, we keep it as yellow or orange. But in actual, when you see, when you light up a candle or something, or the gas, you will see there is a blue region near the wick. So this is where what happens, the wax is burned. Next is the moderately hot part, which is the middle zone of partial combustion. Okay, now the second one is the least hot, okay, or the innermost zone of unburned wax various, which is the black part. Now the fourth part is an outer mantle or not prominently visible surrounding the entire flame. So these are, I don't know what is happening, but these are the four different regions of the main part of the candle flame. Next are what are the products of burning wax. Now water vapor, carbon dioxide and soot are the different parts of the other products of burning wax. Next is what are the following called. These are important. The first one is a phenomenon. I think here is three questions given. A phenomenon in which a substance combines with oxygen, giving out heat and light. So the answer is when a substance combines with oxygen giving heat and light, the phenomenon is called combustion. Number two, which is a substance, uh, the presence of which is essential for the combustion of other substance, is a substance whose presence is essential uh, for the combustion of another substance, which is also called known as the supporter of combustion. Now, an example of supporter of combustion is known as the example is oxygen we can give. Next is a substance that is burnt with a view to obtain heat or light. A substance that is burnt with a view to obtaining heat and light from it is called a fuel. So this is completed. Next question we will go is define ignition temperature of a substance or the lowest temperature of a substance. Now, the temperature to which a substance must be heated before combustion takes place is known as its ignition temperature. This is what we mean. Next question is arrange petrol, diesel, and kerosene in an order of increasing boiling range. This is important. One is the first one is the petrol. Now, the middle one is known as the kerosene, and the last one is the diesel. Okay, so all of you understood. Next is name three gaseous fuels and their sources. Three gaseous fuels are then what are those three natural sources, three gaseous fuels and their sources? They are: first is the natural gas, then the LP, then the biogas, and then comes the LPG, or we can also call as liquefied petroleum gas. Okay, next is name three gaseous fuels and their sources. Now, three gaseous fuels are we can call no are these. Next is describe an activity to show that a candle burns to give water vapor, carbon dioxide and shoot. So, describe an activity to show that the candle burns to give water vapor, carbon dioxide and shoot. These three are very important for fuels. Now, a candle is lit up and after some time some wax near the wick melts and trickles down and resolidifies again. Now, what happens? A glass tube is bent at right angles and is placed at a distance of 10 to 12 centimeter approx approximately. Okay, one arm of the tube should be smaller than the other. Okay, this you should remember when you are trying, and obviously take the help of an elder of your elder. So the mouth of the shorter arm is placed just over the wick and the longer arm is introduced into a transparent bottle. Now it is observed that, oh, I think this is the last question we are doing. So it is observed that the dense white fumes collect in the bottle and condense. So in fact, what happens? The vapors of wax formed just over the wick passes through the tube and condenses the bottle. Okay. Next, the shorter arm is now raised in such a position just above the flame that the gases coming out of the longer arm are tested as what? As the follows that are written downwards, which is the gases are passed over anhydrous copper 2. Remember, you should mention the 2 or else you will not get the full marks. Sulfate is now kept in the watch class. Now, the androus copper 2 sulfate, which is a substance of white, turns blue, which also indicates that the gases contain water vapor. So we have learned that proved that water vapor and carbon is contained. Now we need to prove that soot is also contained. That when the gases are passed through lime water, it turns milky. Why? Because this indicates that the gases contain carbon dioxide. Now you see, you take a stainless steel dish and is held above the flame for a while. Now black solid deposits on the underside. Now this is the solid shoe. I hope you can understand what I'm telling you. So this is how we can prove with this one experiment that candle burns to give water vapor, carbon dioxide, and soot. So these are I think this is the end of my class. Now, if you have any questions, please you can ask me anytime. You can ask me. Please, I will just wait for 10 to 15 seconds. Please like and subscribe my channel, and if you want personal classes, then please do comment below and tell me. And if you need these PDFs, I am always teaching you, and if you need the PDFs, please comment below, or you can go to the live chat also. After you go there, just write down that you need them, and I will personally send the PDF file or whatever I'm teaching to you all, because won't give it publicly, because many are there who is very naughty, and I don't think it is very safe for me myself. And remember, please remember the menti thing that I told you: 50 and 100 questions, two different menti quizzes I will definitely do, but for that I only need just, मेरे अरमान बहुत कम है, बिल्कुल ज्यादा नहीं है, बस 1000 सब्सक्राइबर्स हो जाए फिर मैं जरूर करवाऊंगी। फिर 1000 सब्सक्राइबर्स तब तक मुझे चाहिए जब तक मैं अपना सिलेबस कंप्लीट कराऊं, क्योंकि मैं पूरे साइंस बुक से दूंगी। Okay, so please like and subscribe my channel. Till then, bye bye. I will next meet you tomorrow again. Thank you. Bye bye.